Outline one use for electrolysis of water. Can we use electrolysis for something useful? So to produce hydrogen and oxygen from water for use in fuel cells. But fuel cells have always been kind of regarded as a very new technology that has the potential to revolutionize the electrical industry. And a fuel cell can take hydrogen and oxygen, turn it into water, and produce electricity. So if you had a tank of hydrogen and a tank of oxygen, you could potentially have a water-emitting car, just that you could drive around on your street. Fuel cells are a very, very exciting new technology that might help this whole climate change issue in the future. So one way to use electrolysis is to produce this hydrogen and oxygen for use in these cool new fuel cell things. Why is boiling considered a physical change despite the evolution of a gas? So we look sort of at this at the end of last lesson. The evolution of a gas as an indicator for a chemical change only applies if the gas has different properties to the original material. So remembering that it has different chemical properties to the original material. Since steam has identical chemical properties to liquid water, boiling can't be considered a chemical change because the steam has exactly the same chemical properties as the water, the liquid water. So it's only a physical change. There's no chemical changes at all. Question 8. Write the overall equation for the electrolysis of water and compare it to the equation for the boiling of water. Okay, so water, H2O, forms hydrogen and oxygen, and it's this equation. Now to work that out, what you can do is you can simply just write what you know first. Now this is a really good way of sort of answering a question because chemical equations only balance in a certain number of ways. By writing out all the things you know, you can pretty easily balance this thing out. You know that water turns into hydrogen and oxygen, okay? And you know that hydrogen and oxygen both exist as diatomic gases because you've been studying chemistry very, very hard. We balance these things. When I look at it for the first time, I look here and I say, look, there's 2 hydrogens and there's 2 hydrogens, so that balances, so that's good. And then I look here and it says 2 oxygens and 1 oxygen. So how do I balance that? Well, I put a 2 here. Now the problem is, now I've stuffed up my hydrogen. I've said there's 2 times 2 now, so there's 4 on this side, but there's only 2 on this side. And again, an easy fix, I just multiply this one by 2. And then you can see that that is the same as that. That's one way of answering questions when you don't know what the reaction is, just by writing down all the things that you do know, and then just balancing the equation. Now for the boiling of water, all you've done is you've turned water liquid into water gas. So that's the difference. The electrolysis reaction decomposes water into its component elements, while boiling just changes the state, as you can see. So that's how we compare the two. So it's been proposed to use electrolysis to produce hydrogen for fuel. Performing electrolysis at high temperatures is more efficient economically than at room temperature. Explain why this might be so. Okay, so this is sort of just a right out of left field for you guys. Just pulled this question just to try and get you thinking about electrolysis and chemical reactions in general. It seems like high temperature electrolysis, so making the water hotter, seems to be better than leaving it at room temperature and electrolysizing it. So electrolysis is the consumption of electrical energy to produce chemical changes. We're consuming electrical energy to essentially produce chemical energy. Now, in order to affect these changes, a certain amount of energy is needed. So we need a certain amount of energy to get this reaction to happen. At high temperatures, this energy can be supplied by heat, so we can reduce the amount of electrical energy that we need. So let's say you need X amount of energy, so we need X energy. We could get all of that X from electricity, or we could get maybe half elec plus half heat. So we could get some electricity and some heat. And so we can reduce the amount of electricity that we actually use. Now, again, we're just using one form of energy instead of another. So what's the difference? Well, electricity is much more expensive than heat in nearly every country. Actually, I would say in every country. This results in a net gain in economic efficiency because we're using a cheaper form of energy to substitute for a more expensive form of energy. Okay, that's why high temperature is a little bit more efficient economically than just room temperature electrolysis. So that might be something to keep your eye out on for the future. Maybe it's something that you'd be interested in studying or looking at. Maybe electrolysis will be the new fuel, will produce the new fuel for the future, and it'll be at high temperatures. Question 10, explain why thermal decomposition of a mass of water is more energy intensive than electrolysis of the same mass of water. So if I was to turn, say, 100 grams of water into hydrogen and oxygen by electrolysis, that would take me a lot less energy than if I was to do it by heat. If I was just to heat it up and hope that it works. So when heating the water, the entire mass of water needs to be heated. So I can't focus that heat on one molecule and break it up. I have to heat the whole thing, then something will happen. Now the energy from this heating can be taken up in various storage modes. Additionally, because I've got all these molecules, they can actually store some of that energy by vibrating, by moving, or by rotating. So they could rotate, they could move up and down, or left and right, forward and back, or they could just vibrate. Or they could do all three at once. And so they can actually store some of that energy that I'm trying to heat and use to break up bonds with. Now electrolysis only affects singular molecules of water at a time. And so energy is not wasted in moving other molecules from place to place. Okay, so that's why electrolysis may be a little bit more energy efficient in actually turning it into water, hydrogen, and oxygen. And so this reduces the total energy input for electrolysis because it's not having to affect the whole mass of water, just singular molecules at a time. So that concludes today's lesson on case study of electrolysis and boiling of water. We looked at what the difference is and why they are considered chemical and physical changes. And hopefully these questions were challenging and at least made you start thinking about the whole idea of chemical reactions, physical changes, and chemical changes. So in the next lesson, we're going to look at an actual first-hand investigation of decomposition of a carbonate. So I look forward to seeing you at our next lesson.